Hello, pre-calculus. Today we are going to just review some notes that you learned in Algebra 2. I just haven't done it for a while, so let's see, some vocabulary. If b to the n equals a, then we say that b is an nth root of a. So here's an example. If 3 to the 4th equals 81, then 3 is a fourth root of 81. Example, if 2 to the 5th equals 32, then 2 is a fifth root of 32. An nth root of a is written as the nth root of a, where n is the index of the radical. Okay, so like right over here, I could write that the fifth root of 32 is 2. 2 is a fifth root of 32. Or 3 is a fourth root of 81. Oops. A fourth root of 81 is written as fourth root of 81, where 4 is the index of the radical. Here's some other vocabulary. The radical symbol is that orange symbol. The radicand is what is underneath the radical. We've got an exponent a, and I'm actually going to call that power. It is an exponent, but I'm going to call it power. And then the index we have listed as b, and I'm going to call that root. And then this is a rational exponent. That is equivalent to this radical, the b root of a, or x to the a power. This is a rational exponent on x, on the base of x. So I'm just going to write it over here because I kind of didn't leave myself a lot of room on that side. But we've got x to the a over b. And the b is the root. And the a is the power. Now, I always tell my students that where do roots grow? This is a tree or a plant or something, I don't know. Where do roots grow? Roots grow on the bottom. So that's just a way to remember that roots are on the bottom. And then the top could be like, they don't really do this so much anymore, but they still do. Those power lines. You ever see those along streets? Power lines. So those are up top. Power lines are up in the air. So that's one way of remembering power over root. So before we actually do any examples, it's helpful to know your powers. And if you don't know your powers, right now is a great time to learn them because it'll make your life so much faster. Well, your math life. So 2 to the 1st, actually 2 to the 0. You know what? I'm going to have fun for a moment. I'm going to do about 2 to the 0, 2 to the 1st, 2 to the 2nd. The 2s, we should know a lot of 2s. 2 to the 3rd, 2 to the 4th, 2 to the 5th, 2 to the 6th, 2 to the 7th, and how about 2 to the 8th? We'll go 2 to the 8th. And then I left some space because I'm going to do 2 to the -1 and 2 to the -2. But I'm not going to start there. I'm going to start with 2 to the 1st. We know is 2. 2 squared is 4. Then times 2 is 8. times 2 is 16, times 2 is 32, times 2 is 64, times 2 is 128, and times 2 is 256. There are higher 2 powers, but you don't necessarily need to memorize those. Now, using this pattern, I was multiplying by 2 each time. So we're going to continue that pattern, but we're going to kind of use it backwards so that you can find the other ones if you're unsure of what 2 to the 0 is. Well, it's something that if I multiply it by 2, I get 2. It's 1. Or we can go backwards and look over here. We can just like divide by 2 each time here. So if I divide by 2, then I get 2 to the negative 1 is 1 over 2, and 2 to the negative 2 is 1 over 4. All right, the 3's. I think 3 to the 6 would be the highest I would go. So 3 to the first is 3. To the second, 9. Cubed is 27. Times by another 3 is 81. By another 3 is 243. And by one more 3, we've got 729. Now we can go backwards and just like divide 3 by each time. And that will give me 3 to the 0 is 1. 3 to the negative 1 is 1/3. And 3 to the negative 2 is 1 over 9. Okay, the 4's. Okay, 4 to the first is 4. To the second is 16. To the third is 64. And to the fourth is 256. Now we could keep going, but typically if it's higher than that, it will be on a calculator question where these would all be non-calculator questions. I'm going to go backwards. I'm going to divide by 4. So this one would be, nope, not 0, lied. 1, and then 1 over 4, and then 1 over 16. All right, the 5's. So 5 to the first is 5, then 25, 125, and then 625. Going backwards, dividing, I would get 1, 1/5, and then 1 over 25. Some others, let's see, things that come up a lot, 6's. And actually, before I do that, let's just notice a pattern right here. If I look at 2 to the 0, 3 to the 0, 4 to the 0, and 5 to the 0, every single answer gave me 1. And on the second page of notes, there is a property that says anything to the 0 power is 1. And then you'll notice that when we look at the negative 1 power, what it did was it reciprocated the number. 2 to the negative 1 is 1 over 2. 3 to the negative 1 is 1 over 3. It's reciprocating each of those numbers. So I'm not going to repeat the first 3 in my other category. These are patterns that if you know the 1, 2, 3, 4, 5 powers, you should be able to definitely find these. Non-calculator. So I'm just going to repeat some others, like higher numbers that you should probably have memorized. 6 to the first, 6 to the second, and 6 to the third is 216. Those typically come up. 7 squared is 49. 7 to the third, oops, is 343. 8 to the first, 8 to the second, and 8 to the third is 512. 9 to the first, 9 squared, 9 cubed is 729. And some of these numbers, I don't know if you noticed, some of these numbers come up again. Like when we did the 2's, see, like 2 to the 4th right here was exactly the same as 4 squared. And 2 to the 8th was exactly the same as 4 to the 4th. Because 4 is a power of 2. And so like over here, the 9's, 9 squared is 81. Well, 3 to the 4th is 81. 9 to the 3rd is 729. And 3 to the 6th is 729. So these numbers are coming up again because 9 is a power of 3. Another number that you should probably know a lot about would be the tens. And then I'm going to stop writing all these tens because you just add another 0 on each time. Couple extras that aren't numbers, like x. If I do x squared, I'm going to get x squared. But what if I do like x squared squared? That would be to the 4th power. Or x squared cubed. That would be to the 6th power. Or x squared to the 4th power is x to the 8th. So each of these are powers of x squareds. And then fractions, if I have something like, I'm just going to make some numbers up here, 2 to the 3rd, and I square that, that's the same as squaring the 2 and the 3 separate. Oops. If I have 5 over 6, and I'm taking that to the 3rd power, then I would do 125, which is 5 to the 3rd, and 216, which is 6 to the 3rd. Okay, rational exponents are when we have an exponent that is a fraction. Rational means fraction. It's got the word ratio in it. And so a to the, oh my gosh, a to the m over n, I'm going to write that because I hate when that fraction bar is written like almost vertical like that. M over n, a to the m over n is the same thing as a to the 1 over n, and then that raised to the m power. And then that is also the same thing as, now we talked about this on the previous page, power on top, roots grow in the ground. So that is also the same thing as the nth root of a to the m, or the nth root of a to the m. These are equivalent right here. And then if we have a negative exponent, that just reciprocates, and then we do all the exact same stuff on the bottom instead of on top. So I'm going to evaluate all of these without a calculator, and I'm going to do it using the table of powers that we just wrote out, all of this. Now that is all in my head, so it's going to go fast because I don't have to keep looking. The faster you get numbers like that in your head, it will go fast as well. To get numbers like that in your head, you have to start thinking about numbers and not just using the table the whole time. So what I'm going to do first is I'm going to factor the base. So I'm going to get 16. I could either do 4 squared or I could do 2 to the 4th. That one doesn't matter so much. One of them is probably a little bit shorter, like of work, but either of those is fine. Sometimes it will matter. So I tend to use the smaller of the numbers if it has more than one answer. So I made 16 into 2 to the 4th. Now I'm going to raise that to the 3/2 power. Raising that to the 3/2 power, we have fractions next to each other. That means we are going to multiply, I'm sorry, not fractions, powers next to each other, which means we multiply them. And to multiply fractions, we go straight across. So I get 2 to the 12 halves. Now, that is something you can do in your head, but some people make mistakes. So I'm writing it out on the notes. I'm going to reduce 2 to the 12 halves and get 2 to the 6. And then I find my answer for 2 to the 6, which is 64. All right, the next question, 32 to the negative 3/5. So I'm going to factor 32 first. That is 2 to the 5th. And I'm going to raise that to the negative 3/5. I'm going to put 5 over 1, and I'm going to multiply my exponents. Since they are fractions, I multiply straight across. And I get negative 15/5. I'm going to reduce that, 2 to the negative 3. Now, the negative means reciprocate. So 1 over 2 to the 3. When I reciprocated it, the power got rid of the negative sign because I used that operation already. And then from here, 1 over 8 would be the answer. Here are 4 student practice. I would highly recommend you pause the video and try them. And then unpause and check your answers. Okay, this one here, 4, I'm going to factor that to 2 squared to the 5 halves. I'm going to multiply my exponents. I get 2 to the 10 halves, which is 2 to the 5th, which is 32. 9 to the negative 1/2. 9 is 3 squared. And then if I multiply my exponents, my fractions straight across, I get 3 to the negative 2 over 2, which is 3 to the negative 1. And then the negative exponent means to reciprocate, so 1 over 3. 81 to the 3/4. I'm going to take 81. I'm going to reduce that down, factor that down to 3 to the 4th. And then I'm going to multiply my exponents. And so I get 3 to the 12/4. So I get 3 to the 3rd, which is 27. And then the last one, 1 to any power is just 1. So it doesn't really matter that it's 7/8. I mean, I could rewrite it as the 8th root of 1 to the 7th. And 1 to the 7th is 1. Or, yeah, anyway, 1. Okay, so that's the first worksheet. And then the second worksheet is just exponent rules in general. And I kind of went over some of these in the first part of the video, but every single rule that we have for exponents is written out here. Like the product rule, when we are multiplying same bases, then we add the exponents. If we are dividing same bases, we subtract the exponents. These are all rules for same bases. If you do not have the same base, you cannot use these rules. And then I talked about multiplying the exponents when you do power. I didn't talk about this raising a product to a power. So if we're multiplying some stuff in here and we have it to a power, then we give each part of the multiplication. Each part gets its own power. And then the quotient to a power, you can separate that and give each number that same power, which I did show you a little bit of. An exponent of 1 will always equal itself. Exponent of 0 always equals 1. And then negative integers reciprocate. And then there's some examples that you can look through if you need some extra examples. I am just going to go through the examples here. And when I approach something like this that has a bunch of stuff going on, I always kind of look at the different variables and numbers separately. So 25, x cubed, there's nothing to do to that. Y to the 0 is 1, and z to the 4th. They're all being multiplied. So if I multiply this y value, I don't have to show it because 1 times anything is that same thing. So this one, we've got 28 x to the 3rd multiplied by 1. So just 28 x to the 3rd. Here I have same bases. So I'm going to keep that same base, and I'm going to add my exponents. I get x to the 10th. Now this one, I'm going to separate my numbers from my variables, and I'm going to be multiplying together 2 and 3, m to the 2nd, and another m, which is to the 1st power. So I will get 6, and then for these, since they are the same bases, I will add together my exponents and get m to the 3rd, 6m to the 3rd. Number 5, I'll separate all of these numbers and variables, and I can separate that because it's all multiplication. There's no other signs here. So this doesn't always work. This works when it's all multiplication. So -5 times -2 is 10 times 3 times -2, so -6/10. That's -60. And then we've got a, and we've got to the 2nd and to the 4th. We've got y to the 1st and to another 1st. So 60, a to the 6th, y to the 2nd. Oops. I don't know why this keeps disappearing. Okay. Number 6, we need to be careful because what the exponent is on, if you just go too fast, you might make some silly mistakes because what the exponent is on in this example is just what's in the parenthesis. So the exponent is not on the 3. I'm going to multiply those and get x to the 4th. But on the next one, the squared goes to everything on the inside. So we're going to get 3 squared and x to the 4th. So 9 x to the 4th. Anything to the 0 power is 1. And then I get 3x squared. So 9x squared times 1, which is 9x squared. Okay, I've got same bases and I'm dividing. So I can take that same base and subtract the exponents. That gives me 10 to the -1. When we subtract the exponents, it automatically is like on the top of a fraction. So 10 to the -1, and the -1 exponent tells me to reciprocate. So I get 1 over 10. Okay, my next one is division, but I'm going to kind of divide it up into separate fractions where I look at the numbers, the a's and the b's. So when I do -9 over 12, I'm just reducing that. I do a to the 7th over a to the 3rd. I'm going to subtract. I'm going to take a to the 7 minus 3, which is a to the 4th. And then b to the 4th, b to the 4th over b to the 6th is the same thing as b to the 4 minus 6, which is b to the -2, which is 1 over b squared. So now I'm just going to recombine these 3 things. -3 and a to the 4th are on top. Actually, the negative's just out front, sorry. And then on the bottom, 4b squared. Right, 10x to the -3, y to the 5th. So the -3 exponent is only on the x. 10 is to the 1st power. So x to the negative 3 is the only thing that gets reciprocated, and it becomes 1 over x to the third. So now I'm going to recombine everything, and I get 10 y to the fifth over x to the third. Okay, number 12, I'm going to separate these. I'm going to do negative 15 tenths. And I'm going to do x to the third over x to the fourth. So negative 15 tenths, that can reduce to negative 3 over 2. And then x to the third over x to the fourth is x to the 3 minus 4, which is x to the negative 1, which is 1 over x. So I'm going to combine those back together, and we get negative 3 over 2x. So I'm going to go off on a tangent for just a second. One reason why I hate the fraction bars that look like this is because when I look at this, this is telling me negative 3 divided by 2 and then multiplied by x. This is not telling me the x is on the bottom. This is telling me negative 3 halves multiplied by x, where x would be on the top. So that's one reason why I hate writing stuff like this. So I 100% encourage you guys to be using the horizontal fraction bar. Okay, number 13. 4 has an exponent of 1. X has a negative 6 exponent. Y has a negative 4 exponent. So 4 stays, just 4. X to the negative 6 becomes 1 over x to the 6. Y to the negative 4 is 1 over y to the 4th. And we combine them back together. And then our last one, let's separate 2 over 4 is 1/2. Then we have x to the negative 3 over x to the negative 1. And since they are like bases, I will subtract their exponents. So that turns into x to the negative 3 plus 1. So x to the negative 2, which is 1 over x squared. So I get 1 over 2x squared. Okay, if you guys have more questions when you do the assignments, just send me a message on Canvas or email, or bring your questions to class next time. Have a great day. Bye.